Welcome back. Assume now that I want to solve for the domain of the following functions. These are logarithmic functions depending on some basis, different bases. And want to find the domain. So we'll start with this first one. So here our function is f of x is the log base 3 of x minus 1. Okay. So here we want to find the values that would make this one true. Okay. So we need to have this absolute value of x minus 1 bigger than 0. We want it to be strictly bigger than 0. We don't want to have something that's 0 inside the log, because that would make this one undefined. Okay? And what are the values that would make x minus 1 bigger than 0? So this one, I think sketching of the graph would help us a lot. So the base function here is the y is equal x. Okay? And the absolute value of x is this one. Okay? So if we shift this one by 1 unit to the right, sorry, x minus 1 to the right. So if we shift the absolute value of x 1 unit to the right, it's going to be, let me do it nicely. Yes, it's something like this. So this is x minus 1 in absolute value. Okay, so here, it's this green. Okay, so now we see it's always bigger than 0 because it's on top of the x-axis. It's bigger than 0, but when x is 1, it's 0. That's what we need to avoid. So this one is always true except when x is 1. So we need to remove the 1. So here we remove the 1. To remove that, we define the domain as minus infinity 1, and we jump again to 1 from the right. So it's from this one here to 1, and you jump and you go this line here. So this is the domain, because when x is 1, we have the 0. We don't want to have the 0. We want it to be strictly bigger than 0. Okay, I hope this is clear. So from the graph we see that we get 0 when x is 1. If we don't want to have the 1, we jump the 1. Okay, now let's do the number 2. Number 2 is given by some product, so it's called g of x. It's the log base 4 of x minus 1 times x minus 2 times x minus 3. Okay, in this case we have a product of 3 different quantities. The same thing that we said, this part here has to be positive, strictly positive. So that means x minus 1, x minus 2, x minus 3 has to be bigger than 0. We don't want to use the line and see where the values are. So you have 1, 2, 3, and we check the values. No, there is another way. So we make a table. Okay. Note that when x is 1 or 2 or 3, this quantity will be 0. So to avoid having a 0, x must be different from 1, 2, and 3. Okay, we make a small table. Okay, so the 1, 2, I think I need 4. Yeah, 4. Okay. So on the top, I have the values for x. So x can be anything from minus infinity to plus infinity. Also, I have the values, the zeros of this one. So this is nicely factored, so I can see the zeros, 1, 2, and 3. So 1, 2, 3. Here I can put these factors here. First row, x minus 1. Second one, x minus 2. The third one, x minus 3. And here I have g of x, which is the log, okay, of this one, because when this one is positive, this one is going to be positive. Okay, I'm sorry, I have the sign. Sorry, I have the sign of this 3 because this is my condition. So I have the sign of this 3. Let's call it K. Okay, so when x is 1, this quantity is 0. When x is less than 1, it's negative. When x is bigger than 1, it's positive. This quantity x minus 2, it's 0 when x is 2. If x less than 2, it's negative. If x is bigger than 2, it's positive. This quantity x minus 3 is 0 when x is 3. Okay? It's positive when x is bigger than 3. It's negative when x is less than 3. Now, to get the sign of this one, this k, so I have to do the product. Okay? So here, on this interval, 3 plus infinity, I have all of them positive. So I do the multiplication. Between 2 and 3, I have plus times minus, it's a minus. Between 1 and 2, I have plus times minus, it's a plus. Between minus infinity and 1, I have minus times a minus, a plus times a minus, it's a minus. So now I can read the sign where this one is going to be positive of this k. Okay? So if this one is positive, that means this function is going to be defined. So here I go to my table and I read where the values of x that would make this one positive. So here between 1 and 2, when x is between 1 and 2, it's positive. So 1 and 2. So here, 1, 2, union 3 plus infinity. So when x is in here, in this interval, or in this interval, it's positive. So this is my domain for this function. So when x is in here, my function is positive. My function is defined, and the sign is this one is positive, because to have this one positive means that this function is defined. So I made a small table and I get the result for this one. Okay. Now let's find the domain for this last one. Okay. So this last one is given by h of x. Let me write here, h of x is 1 over the natural log of x minus 2. So here I have two conditions. First, I don't want to divide by 0. So I need to have ln of x minus 2 different from 0. And the second condition that I need to have is that I need to have this one defined. That means I need to have x minus 2 bigger than 0. So what are the values that would make this one different from 0? In another way, what are the values of x that would make ln of x minus 2 equal 0? Let's solve that. Ln of x minus 2 is ln of 1. Ln of 1 is 0. So that means x minus 2 is 1. That means x is 3. Okay? So x is 3. Now, to avoid x equals 1, I need to have it different from 3. Okay? Now, what are the values that would make x minus 2 bigger than 0? So if we add 2 to both sides, I get x bigger than 2. So with this condition and this condition, what do I get? So I get, this is 2. So x is bigger but different from 3. So small circle here. So I get 2, 3, union 3 plus infinity. And this is the domain for this function. So here, this is my domain. Okay? I think I did everything clear here. Well, okay. Thank you very much.